All right, antenna fans, Kate BYP's been going through motor vehicle hell lately. Got the S10 running perfectly after basically having to rebuild the entire cooling system. But back to a previous issue of APS, the last one I got before I told IEEE to go pound sand for lying to me, A, and covering it up or running away and hiding, B. IEEE has a scam going on. When you look on the web and you see a page that says IEEE and you see an email that says IEEE, it isn't. And they're hiding it. And I tried to talk with them about that. They refused to return phone calls and emails. So at that point, they've lost a member forever because I won't tolerate it. What's behind IEEE is this fake front that is actually Right Now Technologies, a part of Oracle out of California. And Right Now Technologies have been accused of fraud, hacking, and malicious activity by somebody online. So I caught them, IEEE's front, lying to me about credit cards, lying about not storing credit card numbers when I caught them and proved that they did. But onward and upward to more stuff about antennas. And we have a historically speaking article, Long Distance Radio Communications 100 years ago. I want to call out some interesting points here. Introduction, long distance communications such as between the US and Europe. I hate this phone. I'm going to kill you. Was often by broad bandwidth signals, dampened sinusoids generated by spark transmitters. That was the first radio transmitter. The first transmitters were a DC source. This is a square function. And from this top of this leading edge over to here to the radio operator's term break, to the break, is an interval of DC. DC cannot be radiated. DC cannot process into LDIDT because the DIDT is zero or constant, and the equation falls apart. What's happening here, this might represent a digital signal. What's being transmitted is this high-speed transition. And that transition can be broken down into what we call frequency, but that's not really what's happening. This is a DT, or a delta T. But what happened, and what is the sinusoid being referred to, this is not a sinusoid. This is a step function. A sinusoid is sine, cosine, tangent, whatever. Sine wave. But when this DC current that was charging an inductor, and the inductor field is charged to the steady state where the current equals voltage over the internal resistance of the coil wire, or the terminal current, when that circuit is quickly opened, what's being emitted is the oscillation, not from the coil. You see, when there's a coil, there can't be oscillation. There has to be a capacitor for oscillation. But the oscillation of the spark across the spark gap. And the reason they were called spark gap transmitters isn't because the spark gap opens the coil. The spark gap is the source of the RF. And that's limited because that's an extremely high voltage transient. That's limited by the breakover potential between the arc terminals. So any potentials below that will represent this, or these peaks will represent that breakover. So these early systems were horrifyingly bad. VLF, 3 to 30 kilohertz. Today, the start of the RF range is 9 kilohertz by FCC. These pathetic systems with extremely short, multiply so-called tuned antennas, which is what this article is about later, is that particularly what they claimed were antennas were not. They were electromagnetic couplings, but they were horrifyingly bad, and that's part of what this article is about. And the only reason they worked is down here. Alexanderson alternator capable of producing a VLF CW signal of 200 kilowatts. 200 kW, to go from the US to Europe, which I'm doing with half a watt. See the problem here? Now, a later part of this article, transmitting facility was to be in form of a wheel with 12 radial spokes, multiple tuned antenna. Okay, this is a fantasy that makes me grind my teeth together that everything that is at the back end of a transmitter is an antenna, and that is false. About 1.5 mile in length along each spoke. 10 200 kW alternators. Whatever deity you hold dear almighty, that is insane power. Okay, we should be able to light up a bank of light bulbs with that and couple some energy to a distance. So their supposed reliable communication to Europe was not because they had antennas or they were any good, it's because of the insane amount of power that they were using. And every metal thing around there is lit up like a Christmas tree, including them. But the fancy of 2 antennas and 2 alternators. Now here's where the problem comes in that I've shown proof of you in my videos, with the fact that sinusoidal signals cannot radiate. Assume the oscillation, and this is talking about an alternator system. Okay, DC batteries can't cut the mustard, so they're using giant motors to drive alternators with very closely spaced windings that allow this alternator to generate 20 kilohertz or whatever. So they're high frequency generators. Then coupling that energy onto this fake antenna system. But looking at the approximately sinusoidal 3-over loop is magnetic, and the frequency omega equals 2 pi f. F is the inverse of T. There's a problem I've shown you that antennas do not respond to or work by frequency. They are purely time domain devices, traveling waves. And what this indicates is that what is not an antenna is just a large inductance, and actually inductance and capacitive coupling with the earth. And that latter part there is the gross failure of this, as this article goes on to explain. The horrifyingly high losses, despite the fact that this so-called multiple tuning appeared to increase the efficiency, the staggering and overwhelming losses in the ground, which is why Ham's attempts to recreate 1930s fake antennas with multiple tunings and ground wires don't work worth a crap. Now up here there's an equation, blah, 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 cos omega t. Cos omega t is the rotational velocity of this sine signal, but sines don't radiate. And if the sine or cos do not radiate, then the sine or cos simply refer to the instantaneous magnitude of whatever's driving or whatever field intensity there is. But that's not the mechanism that causes radiation. And I've shown you in another video that maximum emission is caused when a wire is 90 propagation degrees long and the forward and reflected signals out and back from the end of that wire align. And that's the maxima. And this cos omega t kind of idea simply lets us look at the instant potential at some point along the wire. But that is not radiation. And here's another relation of this idea that the steady state function is not what's being emitted, but it's the spark, the oscillation in the spark gap that results in this. Antenna is simply a CW turned off and on. CW is not carrier wave, it's continuous wave. A spark gap is non-continuous because once the energy in the inductor is used up, then the spark quenches and the signal goes away. The CW came from this big rotating machine. And you see this poor fool here that has built his first MRI. And it should scare the living crap out of you to think of how much magnetic flux is going through his body. This is just scary beyond belief. But it's not the CW that so-called radiates, it's the turned on and off that radiates. And I hate that term because it's not radiation, it's emission. And there's a gotcha here. If it's only the instant off and on, wouldn't we just get a short duration pulse at the receiver? Yes, but if that pulse is then continued on to a tuned circuit, that pulse, and this is EE 101, that pulse is a instantaneous step function that excites an LC circuit back to sinusoidal oscillation. So it looks like, and it's a false illusion, that a sine wave was sent and a sine wave was received when it wasn't. And since what we use to pick up these signals are so-called sine wave devices, inductors, capacitors, tuned circuits, anything we use to examine this is going to make it look like it's a sine wave when it isn't, or might not be. And here's the basis of what I showed to you about the shunt-fed antenna. Notice the two coils A and B, and down here is this alternating device, coil A on the left, B on the right. Notice each coil is two windings on separate parts of the pole, but notice their orientation is different. On the right side, it's a solenoidal form with all the windings in one direction. On the left side, they're opposing. Notice the two coils A and B are magnetically uncoupled, and that's what a shunt-fed vertical is. I mentioned to you that the shunt and the corresponding parallel part of the antenna are a return circuit. That is a 1909 National Bureau of Standards Edwin Rose's paper on various forms of inductors. But on the left here, notice the arrow BA, BA. The two directions are opposite because the windings across these two cores are opposite. So the article says magnetic fields in the two legs of coil A are equal in magnitude and opposite in direction, so their effect cancels in coil B. And what I measured in the shunt is that not only is there no magnetic moment between two, but there's no electrostatic either. And that is how a shunt-fed vertical is directional. And mine are extremely directional. Now, what I've shown you about antennas and the quantum actions is summed up here. The antenna is usually electrically small. I've shown you if it's electrically small, it's not an antenna, it's a field coupling with a typical length, mechanical length being L over lambda, or length per wavelength of 0.1, where lambda is C over F, speed of light divided by frequency, wavelength in free space. And I've shown you that the length for the antenna wire near the Earth with coupling to the Earth is not based on propagation at C, it's based on the propagation velocity of the fields between the wire and the ground. And that's trivial to prove, and I showed you proof of it. Here's where the myth of resonant antenna comes up without sufficient explanation. Figure 8b, the fantasy of an antenna being a circuit. If it's a circuit, it ain't an antenna, and I've proven that to you. Inductance of tuning coils adjusted to resonate the capacitance of the antenna C of A at the frequency F sub naught. 2 pi f squared of LC is the formula for the resonant frequency of an LC circuit. And that C is this fancy of multiple tuned leaders. And the C is the capacitance between the wires and the ground, not the antenna. So this is resonating a tuned circuit with regard to the ground, and the losses are horrifying. For these antennas, and they aren't, eta sub A, eta's efficiency, often very small, only a few percent. So how can they work Europe reliably? They have to use 200, 300, 400 kW, and they're getting 1% out. Is 5, 10, 15, 20 kW nowadays on shortwave, does that kind of agree with fairly reliable shortwave broadcast propagation? Yes. But you see, with piss poor antennas, it takes 10 kW. And with these horrifying disasters, it took 200. To decrease the ground resistance, wires were often buried in the earth underneath and around the antenna. Well, there goes your power. You may as well sit on it because it'll do more good. And here's where hams sit on hot coals with this baloney about their verticals and their ground radials. With his multiple tuned antenna, which isn't, Alexanderson sought to increase the radiating efficiency by reducing the loss in the ground, decreasing R sub G. Conservation of energy, there's the incident energy to the feed point. Either energy is emitted, and there's a percent efficiency as to whether it's emitted in a useful direction or not. If it's going straight up, it's useless. Whether it's lost in antenna losses or it's lost in ground losses. So this implies that if the efficiency is 2%, that 98% of the energy is being wasted in the ground. And this is how I can use my perfect antennas and a couple watts to beat the living crap out of people with these grounded antennas and Yagis. Here's my point of how this so-called antenna theory is completely corrupt. Because they did not know what an antenna or the antenna function was, they had no way to analysis. Our analysis of this antenna will follow simple arguments for explaining improvements by comparing the performance of antennas A and B, same physical size. With no understanding of how it's really working, they've got no option but to do some kind of input current and ground radial current and field strength at some distance and rationalize crudely that A is better than B because A has this tuning mechanism in, and this tuning mechanism does not make an antenna and does not make it better because it's too short to be an antenna. All it's doing is creating a resonant circuit, and that resonant circuit will either create voltage multiplication or current multiplication. So they're banging the end of a horrifyingly mistuned and extremely high resistance end fed simply with a higher voltage. There's going to be more energy coupled, but that is not an antenna. Here's the admission of the problem. The radiating efficiency of an antenna, especially when it's measured in football fields instead of yardsticks, is generally difficult to measure. That's because of this idea that we have to go to the far field to make measurements. And at 20 kilohertz, the far field is in the next county or the next state. So the relative efficiencies having the same field pattern. Well, that ain't going to work because if you drive it with different exciting potentials by having one tuned and one not, the field patterns will be different. So this becomes an absolute nightmare. And it examples the fantasy that pretending that these are antennas because they aren't. Just because one conductor couples energy to another, having a ground return does not make it an antenna. Other measurements determine efficiency single tuned a few percent, and those of multiple tuned, 6 tunings, to be in the low teens percent. So 2% versus 12. They picked up 10% efficiency in this kludge. Okay, they still have to use a 200 kW alternator. It's insanity. And hams are doing the same insanity today, and they expect a different result. And that's why they got to have amplifiers, because they don't even have antennas. What they have is junk. And here's this Frankenstein's kludge. What you've basically got here is a beverage. Other end's grounded. And this is the schematic representation. This is circuits. This ain't antenna. It's got to be fed with insane amounts of power. And here's the key that they did not understand, because they thought that these kludges were antennas, and they insisted that HF wouldn't work. While not as reliable as communication at VLF, well, holy crap, if they're using 200 kW, why wouldn't it be reliable? HF offered a much more economical solution. For example, since the wavelengths are about 1,000 times shorter at HF, the antennas were much smaller and cost less. What's being ignored here is that when the length of the antenna is very, very short, they're able to A, make an antenna that's actually a correct length, and B, which has less length corresponding with the Earth, to couple and waste less energy in the Earth. And there begins the definition of what an antenna is. 15 meters. Highest frequency transmitter ever been built with appreciable power, 15 meters. Amazing, worked on 15 meters. The antenna was about half a wavelength long. That's the magic length that I've shown to you in my other videos. It's got to be exactly that long and not close. 25 feet held up by broomsticks. That's how my piece of junk antennas are held up. I'd go break tree branches off. And the condensers were literally metal pie plates. Signal from HF transmitters received extremely well in South America. Okay, that's as far or further than Europe, because realize much of this was done on the East Coast, and it's only a 1,000-mile trip to Europe. This 15-meter antenna was right under the big antenna, the Alexanderson multiple tune VLF, which was 1.25 miles long, 410 feet high. That's insane. With a crossarm on it, 150 feet long, and a 200 kW alternator. It could not break through the heavy static at VLF, mainly by lightning, that was down there in South America. So the 15-meter antenna kicked its ass and cost a couple percent of what the big antenna did. And frankly, it's not going to kill somebody. How dangerous it is to put up an antenna at 400 feet. You're risking your life putting one up at 40 feet. And so in overview, this goes to show the fantasies, the horrifying incompetence and miserable performance that hams are still hanging their hat on, because they're still practicing these ancient fantasies from 1920. And they think that this piece of crap thing with the tuner and multiple and ground wires are going to do any good. And they just can't understand. And some of them get literally pissed off when I blow them away on the air. And these factors are exactly why, and nothing is going to change until we stop with these idiotic fantasies of resonance and tuners and ground wires, because that's where the power is going. So there it is, a little antenna discussion. Did it? And in the air conditioner, looking at an old bogey movie, I didn't emphasize the most critical point about these early so-called VLF transmitters. They were not transmitting at VLF. They were transmitting at MF or HF, and they didn't know it. At the beginning of the video, I showed you the long duration square wave, which is the function end of charge and inductor, which would actually be a exponential function. And then the sudden interruption. And what was really being so-called radiated was the spark. The long duration, the 20 kilohertz interval, is not what they were transmitting. And that's why their antennas were no good. They falsely thought that they were transmitting at 20 kilohertz. They weren't, because the 20 kilohertz is simply the interval of time between these spark intervals. The spark discharges, and the spark discharges are what were being transmitted, not the 20 kc alternations. And so they had no clue what they were doing. They had no clue that this high frequency spark, they had no way to measure it. They didn't have any radio receivers to tune in and hear that the spark was loused at 2 megahertz. But they were transmitting LF or HF, they just didn't know it.